Hi folks, welcome back. Lesson 5 of the energy changes topic, and this is fuel cells. Just a reminder, this is a chemistry only lesson, so if you're on the trilogy double science course, then you do not need to watch this lesson. Right, here's the AQA specification slide. So this is what they would like students to be able to do. I'm going to spend some time talking about this now because this particular lesson is quite tricky. So it says students should be able to evaluate the use of hydrogen fuel cells in comparison with rechargeable cells and batteries, so-called normal cells. So we'll look at that towards the end of the lesson. In fact, we'll look at a question that brings some of that into consideration. And then there's the higher tier part to this about writing the half equations for the electrode reactions in the hydrogen fuel cell. Now, it's more than likely that in a question they would give you a bit more information. It wouldn't just be to write the half equation. You might need to finish one. But we just need to remember when writing half equations, we add electrons. Yeah, convention is to add electrons. And if you're having trouble with half equations, then go back and practice a bit some more with the electrolysis topic, so the chemical changes topic, so that will help you out. Alright, so at school what we'd do now is we'd have a quick discussion with our peers around us about what we know already about hydrogen. If you're watching this online at home, then just pause the video and quickly just try and jot down in 2 to 3 minutes everything you know about hydrogen. Right, what might you have said? I've come up with a few ideas of what you guys may have been discussing. So here they are. So you might have said that hydrogen has no neutrons. It has a proton number of 1. You might remember about the squeaky pop test, our test for hydrogen. It ignites with a squeaky pop. So the ignition of it's explosive. Okay, in exams now they prefer you to say explosive rather than flammable. To be sure, if it does ask you, I would always say explosive and flammable just to cover both bases there. But more recently, they've gone to explosive as the chosen term. It's got a mass number of 1. It's a diatomic molecule, so it goes around in pairs. There's quite a few on the periodic table. So the oxygen, the nitrogen, the fluorine, bromine, chlorine, they all go around in pairs. They're diatomic. It's a gas, so this links in with our structure and bonding. Okay, it's a simple covalent molecule, so it's a small molecule, and it has weak intermolecular forces, so it has a low boiling point because little energy is needed to overcome those weak intermolecular forces. And you might have said it's a non-metal. But today what we're going to consider is hydrogen as a fuel, okay, and using hydrogen as a fuel in order to save fossil fuels that we currently use as fuels. So hydrogen as a fuel, we've mentioned it's explosive. It can react with oxygen in a combustion reaction inside an engine in order to drive that engine, or we can use it in fuel cells to power vehicles. So what we're going to be looking at today is hydrogen fuel cells. So in both those examples they're both where hydrogen reacts with oxygen. In the initial combustion one, we have less control over what's going on there, whereas in the fuel cell we kind of control the reaction ourselves through using the fuel cell technology, and we generate some energy from that. So the fuel cell is a much more efficient way to use the reaction between hydrogen and oxygen. Quite a lot of the energy produced when hydrogen and oxygen react in a combustion engine, a lot of that's lost as heat. Okay, so it's not very efficient in terms of transferring all of that energy into electrical energy, whereas a fuel cell is much more efficient. In cells and batteries, our reactants get used up and they stop working, but when we use the hydrogen fuel cell, as long as we have a steady supply of hydrogen, then it will keep going for as long as we want it to. The fuels get oxidized, and it's through this oxidation of the fuel that we create the potential difference which then generates our electrical energy. So fuel cells themselves create a smaller potential difference than other methods. So these hydrogen fuel cells do create a smaller potential difference, and that's one of the drawbacks. If we needed a large voltage, we'd have to bolt quite a few of these together to use that. Different fuel cells will use different fuels and electrolytes. We're looking at a hydrogen fuel cell, but it could be in an exam. They might throw a little bit of a curveball in there and give you a different fuel cell. But the same kind of principles apply, and they'd be looking for you to apply the principles we're learning about the hydrogen fuel cell onto the example that they give you. The reactions involved are redox reactions. So this goes back to our half equations that we looked at last lesson and previously in the chemical changes topic. So how does it work? If you're at home or watching online, what you need to do is draw out this diagram in the center of a piece of paper. Give yourself plenty of room around the outside. We'll be annotating the diagram itself as well, so it does need to be a reasonable size. For those of you at school now, what we're going to do is we're going to go on and annotate this diagram. So first thing I want you guys to have a go at is labeling the anode, the electrolyte and the cathode. Now this is where things they will be different to what you've seen in chemical changes and electrolysis. Okay, so if you're unsure, then do just hold back a moment and wait to see where they go. So the anode here is actually on the negative terminal. Okay, and this contradicts what we've done in our chemical changes in electrolysis. You might remember the panic acronym. So positive anode, negative is cathode. All right, but this time the anode is negative here. Our electrolyte is the pink solution in the middle there, and the cathode on the right hand side. So what's going to happen? Right, hydrogen comes into this anode compartment, right, so represented by our orange arrows there. Then on the right hand side, the oxygen comes into the cathode compartment. And we know that hydrogen and oxygen want to react. They want to get together. Okay, they want to become a couple. And what we've got this electrolyte and our anode and cathode in the way. Okay, we're going to control how those guys come together, how they become a couple. We're not going to let them have it on their terms. We're going to decide what happens. So first of all, our hydrogen molecule is going to lose electrons to become hydrogen ions. Okay, so those two hydrogen ions can diffuse through the anode into our electrolyte and head over towards the cathode, and the electrons will be they'll become part of a flow of electrons around. Okay, so that's a current which we'll then be harnessing for our electrical energy. So the half equation there, H2 goes to 2H plus 2 electrons. So remember, it's convention to have the addition of electrons. And because we've got the loss of electrons here, okay, the hydrogen atoms are losing electrons, it's an oxidation process. Right, so our hydrogen then, the H plus ions, sorry, they start moving across towards our cathode. Excellent. So now what you'll notice, the hydrogen ions have gone right across to the cathode, and what happens here is the oxygen gains some of the electrons and reacts with H+. So the electrons that it's gaining, those are the electrons that we've created this flow of electrons around the wire at the top that's going through the bulb and down into our cathode. So those electrons are the ones that we've lost from the hydrogen molecule in the first place, and they've come all the way around, okay, and now the oxygen's reacting with those and then reacting with the H+ to give us our water. And you can see now that the bulb initially was grey, it wasn't on, okay, but now we've got this flow of electrons, this current coming round and creating that circuit and completing that circuit. We've got the bulb on, it's now yellow. So over on the right hand side here, the half equation, if you like, is oxygen plus 4H plus 4 electrons gives us 2 lots of H2O. And here we're having a gain of electrons, okay? So this is going to be our reduction process. And at the end of all of this, we have our water, and the water leaves the system. So the waste product here is water, which is one of the major benefits of our hydrogen fuel cell, that the waste product is water. There's no pollutants, okay, so it's considered to be clean energy. But we'll look at some of the criticism or controversy around it being a clean energy when we evaluate the uses of these towards the end. So the overall reaction here would be 2H2 plus O2 reacts to give us 2H2O. As I said earlier on, we need to look at the advantages and disadvantages of using hydrogen fuel cells over other fuels, okay, or other cells. So rechargeable batteries was one, and other normal battery cells. So the advantages of the hydrogen fuel cell, it doesn't need to be recharged. Okay, so some of those rechargeable batteries, we said they needed to be recharged, and if you remember last lesson, we said how that the quality of the battery over time will degrade. You can't just keep recharging the battery over and over and over. Eventually that quality will degrade and you won't be able to use it at all. But with our fuel cell, we don't need to recharge it, and the efficiency of it is excellent. Okay, it converts a lot of that the energy from the process into electrical energy. So they can actually store more energy than batteries. Whilst they don't create a huge voltage, they can store more energy than batteries, so they will last a bit longer. As we just said, they maintain their efficiency, so they don't need replacing like batteries do. And another major plus that we mentioned just before this slide, there's no pollutants. So water is the product at the end of all of this, which is non-polluting, unlike other fuels, fossil fuels that we might use where we get greenhouse gases. However, we'll look at some of that in the disadvantages too. There can be a range of sizes, so depending on what we need our fuel cell for, we can create different sizes of fuel cells to use. So the disadvantages: hydrogen is explosive. Yeah, really, really explosive. So that there's the danger there of, if there are accidents and the hydrogen vessel becomes compromised and there's a flame, then we could have a large explosion. And it is difficult to store as well. Again, under high pressure, that's really quite dangerous, and that could lead to explosions too. Now then, the hydrogen itself, where do we get that from? At the moment, or at the time of this video, a lot of hydrogen for that actually comes from methane, which is a non-renewable source, one of our fossil fuels, our natural gas. And you'll actually learn more about how we get hydrogen from methane when you look at the Haber process and some of the organic chemistry you'll do later on. So the other issue is that they produce a relatively low voltage compared to batteries. So when we compare these with batteries, the voltage is lower. So if we wanted a high voltage, we'd have to pack quite a few of these together. Right, it's an example of a question here where you're asked to evaluate the use of hydrogen fuel cells compared with a rechargeable lithium-ion battery to power electric cars. Now you've got information in the table there, but it does say to use the table and your own knowledge. So this would be a 6-mark question, and to get 5 or 6 marks, a level 3 answer, you're going to need to use your own knowledge. It's more than likely that the examiners will not be able to give you a level 3 or level 2 in some cases answer if you haven't actually used your own knowledge. Okay, so just you need to take information from the table there and make some comparisons, but you also need to put your own knowledge in. So pause the video now, spend about 6 to 10 minutes trying to answer this question. Excellent. Right, when you're marking these 6-mark questions, it's not just a case of trying to find 6 marking points and ticking them off. Remember I said you have to use your own knowledge. You know, if you're going to get 4, 5 or 6 marks, you've got to have some of your own knowledge in there. So that would be points that come from the other knowledge boxes on this mark scheme here. And then the standard kind of answers, your 1, 2 or 3 marks, they're just going to be making comparisons between the fuel cell and the lithium ion battery. And like I said, in order to get those higher mark questions, you've got to have a combination of those two things. So what you can do is pause the video now and just look through what the mark scheme suggests you should be saying. See what you've got in your answer, put some corrections in, and then you can finish there. Right, that's the end of the energy changes topic. Okay, so the next topic we've got is rates of reaction, and that involves looking at how we can influence the rate of reactions and why reactions actually happen. So if you're moving on to that next, then I'll see you there.